is making a scale factor of her bedroom. So she's already in her bedroom, and now she wants to draw a scale of it, maybe so she can play with furniture arrangement or decide what size bed will fit in her room or whatever. Her rectangular room is 12 feet wide and 15 feet long. On the scale drawing, the width of her room is 5 inches. What is the length? What do we want to do here? How do we quickly solve this problem? What?
Draw a picture.
No, we don't need a picture. What?
Ratios.
Set up a proportion.
Proportion.
Which is made up of, a proportion is made up of ratios. Yep. So, I like to do width over width equals length over length. But if you want to do width of the room over length of the room equals width on the drawing over length of the drawing, you can do that. As long as your right ratio mirrors your left ratio, your cross multiplication will solve it correctly. So I'm going to do, it's 12 feet wide by 5 inches wide. So I'm doing width is to width as length is to length. What we don't need to worry about is that we're in different units. Because when we do feet times inches divided by feet, the feet are going to cancel, and our answer is going to be left perfectly in inches. So the beauty of proportions is that units cancel and there's no converting necessary. So 15 times 5 divided by 12. The length of the room on the blueprint is 6 1/4 or 6.25 inches long. That's all there is to it. That one's simple. Let's try another one. On a blueprint, 1/8 of an inch represents 1 foot. If the height of a wall is 1.5 inches on the blueprint, what is the real height of the wall in the building? So we're going to stop right there, and then we'll answer this other question secondly. So this will be our A question. This will be B. So go ahead and find the height of the real wall. So we use a trusty old proportion. That's all you do here, especially since it's kind of confusing. They gave us fractions and decimals, but the great news is a proportion can handle all of it. So in my proportion, I'm going to choose to do inches is to feet as inches is to feet. I'm going to use my scale first. 1/8 of an inch equals 1 foot. And then the height of the wall is 1.5 inches. I already know where to put it because I labeled my ratio. What's our answer automatically going to be in without us doing any work? What units is our answer going to be in? Look, yeah. X is already slated to be feet. Without any converting, our answer of the real building is already going to be in feet, and that is great news. So we just do, pretty much we're just doing 1.5 divided by 1/8, because 1.5 times 1 is 1.5. We ask our calculator, divided by 1/8. There's no reason to try to do that by hand. It's not necessary. And we get 12 feet. So that's how tall the wall is. Is that a reasonable answer, a wall being 12 feet tall? Do you agree? Always check your answer to make sure it's reasonable. It's totally reasonable. That's like twice the height of a tall person, 6-foot person. I think it's totally reasonable. Okay, here's where things change. Scale factor. I want you to write down scale factor, and then I want you to write down units matter. In a proportion, the units canceled. I'm not saying they don't matter in a proportion, but they take care of themselves in a proportion. But in scale factor, sure, Jenny, but with scale factor, the units matter. So I'm going to do my scale factor, second over first. That hasn't changed. So the building is second, and the blueprint came first. So I'm going to do building over blueprint. So my building, 12 feet tall wall, and my blueprint, 1.5 inches. That is not a scale factor. Right now, or I could have used, never mind, I want to use the scale they gave me. I want to use this. So second over first, I'm going to do the real building over the drawing. That is not a scale factor yet. What we want to do is make the top units match the bottom units. So I'm going to put everything into inches. So instead of 1 foot divided by 1/8 of an inch, I'm going to do 12 inches divided by 1/8 of an inch. Scale factors are unitless. Scale factors have no units. So the units need to match. When they match, they cancel. So when I do 12 divided by 1/8, I get 96. And 96 is the scale factor. Scale factors do not have units. So don't put 96 inches. Don't put 96 feet. Don't put 96 kilometers. Scale factors are simply a multiplier. 96 is the number that gets you from the blueprint to the building, and it is unitless. The units should cancel. And we're going to try 2 more if you have time. An architect built a house from the blueprint shown. He used a scale of 1 inch equals 8.5 feet. What is the scale factor used to enlarge the image?
The screen hasn't updated. The screen's still on the previous thing. That's not the update. It's not me.
So I'm going to put second over first. I'm going to put 8.5 feet over 1 inch. That was the scale we were given. 8.5 is not the scale factor because those units do not cancel. So instead, I'm needing to convert 8.5 times 12. Notice we're converting from feet to inches a lot. And I get 102 inches, which since the denominator is 1, we're already done. That's our scale factor. So the real house on this one is 102 times bigger than the scale drawing. All right, last thing. Now it's the same picture. And we have this tiny little bathroom. They tried to fit a bathroom in there and squeeze all the stuff in there, but it's tiny. On this drawing, it's 3/4 of an inch by 1/2 of an inch. This time, I want you to use the scale factor to find the length and the width of the real bathroom instead of using proportions, because we can use either one. The scale factor is 102. So I'm going to use my scale factor and just blow this up. Make it bigger. So 3/4 of an inch times 102, and then 1/2 of an inch times 102. All right, so we get 76.5. Now, what is that? Is that feet or inches? Good. We started with inches. Our scale factor didn't have any units at all, so we ended with inches. And if you want that to make more sense, you can divide it by 12 and make it feet. So 1/2 times 102, 51. So those are the dimensions of the bathroom in real life. But like I said, if you want it to be more of a real world answer, divide them both by 12 and put them in feet, because right now they're still in inches. Martin notices that the top of a tree coincides with a blimp along his line of sight. That's a really good noticing job, Martin. Martin's, that bugs me, eyes are 4 feet off the ground. Okay. So from his eyes to the ground, we've got a good old 4 feet. He is standing 15 feet away from a 10-foot tall tree. 10-foot tall tree. He is 15 feet away. How far off the ground is the blimp? Ooh. So there is a definite trick to this problem. There are 2 ways to do this problem. I will show you. I will introduce both ways, but I'm only going to do it the easier way. The problem is we've learned about similar triangles and how to set up proportions with similar triangles, but not really any other shapes. So you need to turn these into a triangle. You can do that by a fancy trick like extending that. But that way is a little bit more complicated, even though it will work. Instead, I'm going to show you a really cool trick where you start from his eyes and you draw a horizontal line straight across. When you do that, you create two similar triangles, and now you could use proportions to solve for the missing side. So what we want to do now is make sure we've got all the measurements we need. Let's see. If the tree is 10 feet and he's 4 feet tall, 10 minus 4 makes this 6 feet right here. I'm going to bring this 15 up. We know this is 15. And feel like we need one more thing. Okay, this problem definitely needed more information to solve it. I don't know who wrote this. All right, so I've added some more information to make it solvable. It's always good when problems are solvable. I said the base of the tree is 35 feet from the base of the blimp. So I went ahead and added that extra information so we can move this 35 up here. So now we're ready to write a proportion, and we're trying to solve for y. We can't solve for x yet. We need to solve for the side that's actually part of a triangle. So I'm going to say 6 is to y. So I said 6 is to y as 10 is to, and here's where we need, oh, sorry, that's not 10, that's 15. Here's where we need to be careful. So I'm using this 15. I better not put 35. I better say 6 is to y as 15 is to 50, because I need to use the whole side of the triangle. 35 plus 15 is 50. I know, just a second. So I cross multiply 6 times 50 divided by 15, and we get y equals 20. We need to be careful. Now we know this is 20. We know his height is 4. So how high is the blimp off the ground? The final answer, you have to add that 4 back in. Final answer is 24 feet.